Hello, Year 9. Welcome back. Science. In your lesson yesterday, you did an Oak National Academy video about the 4 models of the atom. So what we're going to do today is we're going to just briefly recap that, make sure you've got a super useful note in your book about it. We're then going to do some general recap work on models of the atom and chemistry in general. Then tomorrow and then after this, you're going to do your carousel quiz, which I'm going to check. And then tomorrow you have your Find Out Friday, which you will also do on carousel, but there are no flashcards for it. And I will check that in very careful detail. And then next week we will start a new topic. Okay, let's get cracking. So we're going to need our periodic tables today, but we'll get those later because we don't need it just yet. We're going to start with the 4 models of the atom. Now, the way we're going to do this is we're going to do it in kind of like 3 chunks. So first, I'm just going to do lots of verbal question and answering, and I'm going to ask you questions about these models of the atom and then take some notes. And then what I'm going to do is I'm going to start deleting bits from my notes and ask you to write them down for yourself. I'll explain exactly what that means later on. So basically, we've got 4 models of the atom. What was the name of the first model? So if this one is, sorry, go away. Okay, this one is the first model. What was the name of this model of the atom? Call out your answer to the screen on 3. What was the name of the first model of the atom? 1, 2, 3. Well, I'm hoping that you remember it was called the Dalton model, named after a British scientist called John Dalton. Now, you notice that it doesn't really have much in it, and we just call it a hard, indivisible sphere. And that indivisible, so there are 3 words there. So hard, and I guess what we can do is just call it the indivisible sphere, right? Indivisible means you can't break it down. It's got no smaller parts. And sphere, as you know, means like a 3D circle. Okay, so the way that we like to talk about the Dalton model is a bit like a kind of a snooker ball, almost. All right, the next one, and that's it. That's pretty much it. The next one already starts to have these little pluses and minuses. What was the name of the next model? This model here. What was the name of this model? Call out your answer to screen on 3. 1, 2, 3. This is called the plum pudding model. And it's got these little things here that we need to talk about, and it's got this thing here that we need to talk about. What are those little things with the minuses? Call out your answer to screen on 3. 1, 2, 3. These are electrons studied in. So those negative electrons, they're like fixed in position. So the plum pudding is a bit like a big cake. And if you stick plums or raisins in it, so the raisins are like the electrons, but then the whole cake is spread out positive charge. And I guess the only way to really kind of conceptualize what it means, to understand what it means that it's a spread out positive charge, is it's a bit like when you take butter and you spread it on bread, right? So instead of having, if you start with the butter on your knife, that means the butter is all in one place, and then you spread it out on the bread. That's a bit like what this positive charge is. Instead of having the positive charge all like up at one place, it's spread out across the whole thing very thinly, like thin butter on bread. The next model is this one down here. What was the name of this model? What was the name of this model? Say your answer on 3. 1, 2, 3. This was the nuclear model. And here it's got a positive nucleus. And you can see that it's not a spread out one. You remember like we spoke about the butter? So the butter here is like it's on the knife. It's all in one place, whereas here it's all spread out. And it's also got these electrons. And those electrons, they can kind of move around and they go wherever they like. Now, the last model is this one. This is called the electron shell model. what is this ring called? Call out your answer on 3. What's the ring called? 1, 2, 3. That is, of course, called your electron shell. And what is this minus? Call out your answer on 3. 1, 2, 3. There's your electrons, and they orbit the nucleus on the shells. So there you have a summary of everything that you learned in that Oak lesson. There is, of course, a bit more to know than that, but for us, for the minute, I think that will probably be enough. Now, I'm not going to ask you to copy all of that down. What I'm going to do instead is I'm going to ask you to, what I'm going to do, I'm just going to copy this, right click, copy, and then let's place it here. There we go. Now, what I'm going to do is I'm going to write letters where I want you to answer a question. So down the side of your page, okay, don't do anything yet. Down the side of your page, you're going to have A, B, C, D, E, F, etc. And I'm going to write letters where I want you to do something. So for example, A is going to be to name the model, and you would write Dalton over there, because that's what it is. And then if I wrote B over there, you would write plum pudding in your book. And it's like questions that you can then answer. So I'm going to delete those because that will make it a bit easy. That will be C. That will be D. I'm also going to have some arrows saying just to kind of describe what it's like. That's C. That's D. E. I know we've already done B, C, D, and E. I'm losing my marbles today. So that was A, B, C, D. So this will be E. That will be F. That will be G, H, I, J, and K. So you should, in your book, go down A, B, C, D, E, F, G, H, I, J, K. Pause the video, answer as many of these as you can in your exercise book. Okay, you should only be listening to my voice now if you've answered those, and you should get a purple pen ready. Okay, let's go through. So A, we know is the Dalton model. B is plum pudding. C is nuclear. And D is electron shell. Now, sometimes the electron shell model is called the Bohr model. E, where's E? E is over here. So that's the indivisible sphere. Indivisible. No, I spelled that wrong completely. Indivisible. Oof. Sphere. F is over here. So that's our spread out positive charge. Did I skip G? Yeah, so there should be a G there. Silly. So these are negative electrons, and we say stuck in or studded in. Stuck in. H, where's H? Are more negative electrons. I is your positive nucleus. J is your electron shell. And K is your electrons orbit the nucleus on the shell. Okay, let's do some points for you guys. We'll get 1 for that, 1 for that, 1 for that, 1 for that, 1 for that. Let's do 1 for positive charge and 1 for saying it's spread out. 1 for negative electrons, 1 for stuck in, another for negative electrons, positive nucleus, electron shell, and then electrons orbit the nucleus as your last one. So make your corrections and count up your points. Pause the video. Okay, you should only be listening to me if you've done all that. What I'd like you to do as then your next activity is just get all this down, including those diagrams. They won't take you long to make. And make sure you've got that in your book as a perfect, beautiful note. So pause your video and get that down for me. Cool. Now that you've done that, let us do some just standard chemistry questions. I'd like you to have a go at these questions, please. We've done these many times before now. Pause the video, answer the questions. Right, you should only be listening to my voice if you have done these questions. Let's go over the answers. What is a mass number? That's the number of protons plus neutrons. What is an atomic number? It's the number of protons. Mass number of xenon. So we go to our periodic table. We find xenon, which is over here. So the mass number is 131. And the atomic number was 54. How many protons, neutrons, and electrons are there? So protons, neutrons, electrons. Protons was 54. Neutrons is 131, take away 54. Got my trusty calculator, so I'll just use that rather than doing it by hand where I could make a mistake, and that would give me 77. And my electrons are also going to be 54, because remember, these are always the same. What group and period is xenon in? So again, we've done this before. So it's in group 0 and period 1, 2, 3, 4, 5. So group 0, period 5. 0, period 5. Xenon is an element. What is an element? It's a substance made of one type of atom. Whereas a compound is made of two or more different, and you have to have that word different. If that word different isn't there, it's wrong. Different atoms, and you need to have chemically bonded. And you have to have chemically bonded. I'm hoping by now you can do this from memory, and that'll be Dalton, plum pudding, nuclear, and electron shell. And then you're done. Let's do some points. 1, 2, 3, 4. Let's go 4, 5, 6, 7, 8, 9, 10, and 11 over there. So 11 points there. We did how many points in this one? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that'll give us 24 points in total. Let's pop those into our tracker at the front and listen to me very carefully. Following this video, you are going to do your quiz on Carousel. If you get less than 70%, retake it, go back to the flashcards, and then retake the quiz and impress me. I don't want any of this nonsense where you're just like clicking, 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 or you're getting rubbish scores and you're not doing anything about it. It's not good enough. And then tomorrow, there will be another video followed by your Find Out Friday. Thank you for listening, and I look forward to seeing you again soon.